Hello, everybody. Just giving it a few more minutes as people continue to join us. We'll probably be starting in the next 3 or so minutes. Hello, everybody. So it's about 12:05 now, so it's a good time to start. So welcome, everybody, to today's OPWA webinar titled Progress Updates on Toronto Portland's Flood Protection Project. The presenter is Ken Gaya from Waterfront Toronto. This webinar is a part of Ontario Public Works Connect program organized by the OPWA Education Committee. My name is Alexander Andrikov, and I'll be your host for today's webinar. So a little bit on OPWA for now. Start off. So OPWA is a non-for-profit organization of professional public works practitioners. We are the Ontario chapter within the Canadian Public Works Association, CPWA, and one of 63 chapters of the American Public Works Association, or APWA. Just want to make sure that we have about 500 members who are employed by provincial governments, municipalities, consulting engineers, utility companies, contractors, and suppliers across Ontario. The chapter is also set up geographically within 2 branches in the Niagara region, and which kind of takes up the West Central branch, and the Ottawa region, which is the Eastern branch. So OPWA's mission statement, connecting the public works community, and it's exactly what OPWA offers to its members, opportunities to connect through workshops, conferences, and social events. Ontario Public Works Connect is a learning program to help connect memberships with members with technical educational resources, as well as connecting with OPWA members who are experts or trained in their sector of public works. These monthly webinars are hosted by OPWA. It's just one example of providing value to the membership. To learn more, please do visit the website if you're interested in joining or finding more about upcoming webinars. We also have 2 events that are coming up. We have the Ski and Snowboard Day at Off-Road Bluff Ski Hill on February 24th, and the International Women's Day Seminar on March 10th. Of course, another great way to connect is to join the OPW committee, one of many committees. So yeah, we'll really appreciate your volunteer assistance and ideas. All right, so I guess onwards to today's topic. Okay, so before kind of proceeding, one quick introduction. So Ken Dion is the project director from the Portland's integration for the Portland's integration for the Portland's flood protection project at Waterfront Toronto. Previously, he worked at the Toronto and Region Conservation Authority between 2001 and 2018. Most recently, as a senior manager in the project management office. He's overseen the planning and construction of large-scale projects involving flood and shoreline protection and aquatic and terrestrial habitat restoration with a focus on integrating natural systems with sustainable city building. He holds a Bachelor of Science in Physical Geography from the University of Victoria and a Master's in Physical Geography from McGill University. Before Ken proceeds with his presentation, just a few notes for the webinar itself. So participants' microphones have been muted and the cameras will remain off. Questions will be addressed in the conclusion of the webinar. If you have any questions, please do place them in the Q&A box. The Q&A icon is located at the bottom edge of your screen. So you just click the icon and enter whatever question you may have. The webinar is approximately 1 hour long. And without further ado, Ken, take it away.
Thank you very much, Alex, and thank you very much for inviting us to present with your webinar series. We're looking forward to giving you a brief update of what the project is about, if you haven't heard about it over the last few years in the media, and where we are in the progress and when we're going to be completed this project here at the mouth of the Don River in Toronto. The presentation is broken down into 4 main groups. The first one is a bit of an introduction of what Waterfront Toronto is. And then getting into the project need and challenges and the goal and objectives. Then we'll get into some of the project components. It is one project, but it's actually consisting of about 23 different large projects, all sort of combined under one umbrella, and get into the details of the construction progress itself. So, who is Waterfront Toronto? We are created through provincial legislation. We are an agent of the 3 levels of government, provided we receive funding from all 3 levels of government, funding from 3 levels of government. We are looking to revitalize the waterfront in Toronto at Lake Ontario. We're looking to transform past industrial sites into thriving, complete neighborhoods that support economic vitality and improve the quality of life of people who live here, as well as visitors, and provide excellent major attractions for the broader Toronto and regional area. We are working on behalf of Torontonians, Ontarians, and all Canadians to make a great, vibrant waterfront that belongs to everyone here in Toronto. As you can see, I'm not sure if there's a way I can just move that there. This is our designated waterfront area. We also have a couple of projects working with TRC in the past, with Port Union and Mimico, but you can see this is basically covering most of the inner harbor area, Portland's area, as well as going out to the west for the Toronto waterfront. And some of the critical challenges and opportunities that Waterfront Toronto leads is looking to create sustainable, cutting-edge solutions to reduce carbon emissions, promote high quality of life, and basically to try to create healthy people living within the city. We are looking to create complete communities that address needs for housing, mobility, accessibility, connectivity, inclusivity. We try to create spectacular new destinations as part of our work, designed along vibrant cultural, recreational, ecological, civic, and public spaces. And a core piece of our work involves extensive engagement with the public, stakeholders, First Nations, and developing a really integrated way to access the broader public. We've had a significant amount of success. As you can see here, over 2.5 million square feet of development has occurred. with over 2,600 market residential units. We have received generated revenues to the government in the order of 1.6 billion. We've created $4.1 billion worth of output to the Canadian economy. Basically initiated $21 billion of total investment on the waterfront, as well as $2.6 billion development value attracted by Waterfront, first initial projects in the area. So let's see if I can get this. So getting into the project itself, the Portland's Flood Protection Project, project challenges and goal. As you can see here, we are located at the mouth of the Don watershed, which flows from the Oak Ridges Moraine down to Lake Ontario. It covers about 36,000 hectares, flowing 38 kilometers south, and is one of the most, if not the most, urbanized watersheds in Canada. The project area is right at the mouth. So as you can see, the area in yellow is the location of our various project elements that we are in the process of implementing. And you can see where the Don River comes underneath the Metrolinx GO train line, underneath the Gardner ramps, Lakeshore Boulevard before entering into the Keating Channel, which then does a hard right into the inner harbor of Toronto. So we are looking to provide major new flood protection and city building environmental enhancement works in this project area. Of course, this is not what has been here forever. This is all created lands that occurred over 110, 120 years ago. This was one of the larger coastal wetlands on Lake Ontario, Asperger's Bay Marsh. And as an effort to address disease when they had raw sewage being discharged into the wetlands and a lot of mosquito-borne disease, but also they wanted to create a whole new industrial port operations area at the time. And as such, extensive filling operations were undertaken over a period of 10, 15 years to transform the marshes into the portlands that we see today. Of course, it was not the environmental rules those days that we have now, and it was a significant amount of garbage and waste materials that was contributing to the creation of the land base at that time, creating a legacy of impacts. After the portlands were created, there was a significant, I apologize for the phone in the background. You can see there's a legacy of industrial activities that occurred. Oil refinery was extensive in the area, and as were munitions production and tanneries and a series of other activities that created significant further contamination to the soils that were placed in the portlands in the day. And as a result of this lake filling activities, what happened was we ended up with a very low lying topography surrounding the Don River and Keating Channel that basically created very flood vulnerable location within the broader surrounding area on the Toronto waterfront. What you see on the left was 210 hectares of flood vulnerable land from that was originally on the west side of the Don River. Flood protection works were completed between Waterfront Toronto TRC and the City of Toronto in by 2012 through the West Don lands and the lengthening of a railway bridge that actually eliminated the flood risk. We are now working to eliminate the remaining 290 hectares of flood risk that occurs to the east and south of the Don River through the implementation of the Portland's Flood Protection Project. So this is the more detailed sort of residual flooding that is flood risk that is expressed within this area that will be addressed through the Portlands project. We are dealing with regulatory storm flows, which in Ontario involves the highest flood record that occurred, the largest volume of flooding that has occurred on record. And in this case, for Toronto area, Hurricane Hazel was the regulatory flood event. And this is a massive flood event that's far larger than the 1 in 100 year storm event. To give a bit of an idea of the range of flows we're dealing with, the Don River in a typical summer is around 2 to 4 cubic meters per second, just 2 to 4 meters per second flowing down the Don River. The regulatory storm events, we're looking at 1,572 cubic meters per second that we are trying to provide accommodation for. So it's a much larger volume of water. The 100-year storm is about 500 cubic meters per second to give you an idea of the quantities of that we're managing. Another major issue we're dealing with this project is the fact that we have significant amounts of sedimentation and debris that occurs in the Don. It's always been known as a very sediment-laden river. The river comes through some very large bluffs upstream, and with the amount of industrialization, urbanization upstream, significant amount of sediment and debris does come down. We're looking at 30 to 40,000 cubic meters of sediment that is deposited in the Keating Channel every year. That material is not going to disappear when we implement the project, so we do have to continue for an adaptive management approach for dealing with the sediment. And we get almost 1,000 tons of floating debris coming down from upstream, which is important to manage so that we do not have impacts and conflicts with navigation in the inner harbor, but also the fact that we are looking to create a very green and naturalized river mouth. And we want to minimize the amount of refuse that gets trapped within our naturalized areas that we're establishing. The habitat conditions, of course, currently, that's very, very poor habitat. It's all dock walls going several kilometers upstream. The Keating Channel is deep, uniform conditions, up to 6 to 7 meters deep. There is very little structural habitat within the Keating Channel and Lower Don. There's essentially no riparian vegetation. And as you can see in the foregrounds, given certain summer conditions, we can get some very poor water quality conditions with low oxygen level and high phosphorus that can create significant filamentous algae blooms that occur within the area. And the fish communities and the diversity of wildlife is quite low right around the Keating Channel itself. So we ended up undertaking an environmental assessment, which was completed in 2015, which sought to select the best solution that was going to create a naturalized river mouth while providing flood protection up to and above the regulatory storm event, within the context of being in Canada's largest city area. So we had to deal with existing infrastructure, existing land uses in the area, and plan for future revitalized sustainable communities into the future as well. So the components, this gives you a bit of an idea of where we were following the EA approvals. This is the Portlands. You can see the Keating Channel over on the left of the screen. We had the overhead Gardner ramps coming through the area, lake shores underneath the Gardner, and a lot of derelict industrial lands within the area. And through the EA process, we create a new naturalized river mouth that has 3 different outlets to allow floodwaters to find its way into Lake Ontario. So we are, you'll note, keeping the Keating Channel, which is deep and wide and actually offers a significant amount of flood conveyance capacity. So it also provides a great opportunity in a sustainable revitalized community to provide some nice formalized public promenades that allows public access and cafes and different sort of opportunities for the public to experience the dock walls that are in there. But you'll also note that we are creating, through a combination of cutting a new river valley system and raising the surrounding lands, that could create a new naturalized meandering river system with associated wetlands behind the levees. and a whole network of trail systems that allows the public to experience nature in the river that is being created. And we have, this will be taking the base flow conditions the majority of the time. We are putting in a flow curtain in this location here that diverts most of the base flows into the river so that fish know which way to move up the stream during their migrations. And we also have a levee that is located in this location here, which is at quite a high elevation. But what the intent of that levee is, during large flood events, around the 50-year flood event, water will overtop that levee and go into the third outlet, which goes into the ship channel in this location over here. The vast majority of the time, this outlet is actually providing the highest quality wetlands that is in the entire river system. And it is fed primarily through Lake Ontario water rather than the Don River. And it only becomes part of the river during the large flood events. During a 2-year flood event, what happens is this flow curtain that I mentioned earlier becomes loaded by the flows. It disconnects from the dock wall, swinging open, and maximizes the amount of flood flows into the Keating Channel so that we can reduce the erosivity of the extreme flood events in our naturalized areas, trying to eliminate some of the urbanized hydrology that is contributing to the entire, contributing from the upstream watershed. And to deal with sediment, we are creating a sediment trap north of Lakeshore. We do have to actually widen and deepen the river north of Lakeshore to get underneath the Lakeshore bridges. And as soon as we widen and deepen the river, sediment deposits in that location. So we have to come up with a new system for dredging and removing sediments north of Lakeshore if we are to retain that conveyance capacity under the bridge. So we are doing a detailed operational plan for managing sediment north of Lakeshore as our primary location rather than in the Keating Channel where it is currently undertaken. What you can see here is, this is one project, but it consists of about 23 other major projects broken into various types of works. We have park works, which are in the green. So we're creating an area of parks and open spaces. We also have bridges, which are in the pink. We are creating islands as part of the river new design. So we have to install a whole series of new bridges. We are raising the grades leading to those bridges in the surrounding lands and on the islands. So we have to create new roads that are associated and all the municipal servicing and infrastructure that's associated with it. We have the new river system itself. And we have a series of different types of marine structures, such as the sediment management area, flow curtains, deals, and a flood protection landform along the Don roadway south of Lakeshore, which allows us to be able to get the regulatory flows contained and conveyed into the lake so that it does not spill to the surrounding future development areas. And ultimately, the idea is to have, for the most time, a green and blue, or brown water, but you get an idea of naturalized river and wetland systems. But under the flood events, we do have the water levels basically utilizing the green infrastructure as the conveyance area. And as the flood hydrograph goes by, we are left with the green spaces with some relatively minor maintenance operations, cleaning sand and debris off the park space, the river spaces, but we do have conveyance of the river system, of the flood during a regulatory storm. So there's a lot of benefits from this project. It's a $1.3 billion project, but we're adding $5.1 billion in value to the Canadian economy. It's creating a significant amount of revenue for the government with the direct and indirect opportunities of development within the area. There's a heck of a lot of employment that's coming from the work directly and the subsequent development that will follow. We are looking to create a significant increase of people living within the area with a significant amount of affordable units. We're creating 11 hectares of parkland and 13 hectares of coastal wetlands in the area. So it's a huge increase in biodiversity and public green spaces and creating a new paradigm for sustainable and accessible communities in the area. So some of the technical challenges that you may be interested with the project, as we mentioned, this is a lake fill area. It's heterogeneous, unconsolidated, very underlined by peats. So it's very compressible, very unstable, and of course contaminated. And so that created significant challenges to being able to excavate a river valley that's essentially at Lake Ontario water levels with high groundwater conditions, to be able to put a clean and green naturalized wetland on. So one of the things we had to do is create a lot of isolation. So we created a really big foundation and basement for a natural river system through heavy engineering processes, through a series of cutoff walls. These are created to basically ensure that our valley slopes never collapse into the future surrounding the valley, but it would also provide us the ability to actually excavate and dewater the river valley system while we were doing the construction in the dry. And this allowed us to provide us the ability to create the horizontal and vertical barriers from contaminants that are left behind in the future development blocks, as well as the underneath of the river valley, so that we're not creating pathways of contamination into the ecosystems. And these cutoff walls are essentially keyed into bedrock that allows us to drop Lake Ontario water levels out and isolate it from the entire project so that we, without having to try to dewater Lake Ontario during the work. And we had different types of solutions. We had secant piles, slurry walls, a hybrid of slurry walls, diaphragm walls that we were incorporated in the overall design. And you can see, depending on the location where we were, the physical conditions varied based on the depth to bedrock and the complexities of the soils and the importance of isolating and structural components. We used a various template of these different types of reinforcements, depending on the geography of the project. One of the big ones, which was some of the first works that we did, is we did secant piles. These are basically 1.5 meter diameter vertical concrete piles that overlap by 25% on either side of each other, and every second secant pile has steel H pile driven down to bedrock. These range from 13 meters to 45 meters depth, depending on the location where bedrock was. This allowed us to create an impervious barrier from the adjacent lands that aren't going to be part of the river, so that contaminated groundwater can't migrate into the excavation site. And these were self-reinforcing walls that allowed us to drop the river valley by 8 or 9 meters inside to remove the contaminated soils where we'll be creating the river valley system. Some of the other areas where we didn't have, it was a temporary wall and a barrier that was required, but we didn't need a structural component. We used a technology called a slurry wall, which basically had a long reach excavator excavating down a long trench. As at the same time, we had an injection of bentonite and concrete installed into the trench, and with the mixture of the groundwater conditions and the bentonite, it allowed us to create an impervious wall that allowed us to dewater the excavated area where we didn't have a structural component that needed to maintain its integrity. That worked out quite well for us. And in some locations, we did the slurry wall, but we did need a structural component, and we integrated it with a hybrid of steel H piles so that it did have some level of reinforcement to be able to maintain the barriers. And then a unique piece of work that we had to do is where the river is going to be discharging. It's the new naturalized area, which is over at Polson Slip near Cherry Street. This is the site of the old T&T grocery store, if you know the Toronto, Portland's area at all. This was unique. We needed to create a barrier that allowed us to excavate the river mouth in this location, but we also needed to excavate on the wet side of it, lake side of it, before we did the naturalization side of it, so that we can actually put in a new bridge in this location going into the slip. So we needed to create a barrier that actually was able to withstand the loadings of of the soils being left to the east of the barrier, while we excavated to the west of it to allow for the bridge. But then it needed to be strong enough to withstand the loadings from the lake afterwards when we removed the soils to finish the excavations to the east of it, so that it was a completely supporting structure. So basically we had an interesting infrastructure piece of equipment that came in and created a series of deep excavations where material was dug out. We placed in a steel cage reinforcement, and then it was filled in with a concrete to create the stability that's required for the different forces that will be exerted on this. And when we are completed with this, the need for this, when we need to open up the river mouth entirely after the river has been completed, we'll be bringing in these big diamond saws that will actually allow us to cut out chunks of the concrete and reinforced steel to be able to provide that connection. And of course, we would have to raise the water levels into the river first before we open that up. Otherwise, we'd have of course, a flood wave of water from the lake entering in an uncontrolled fashion. So we need to create an equilibrium there first. Water management was important. So even though we were able to isolate the excavation, there is still a lot of water that comes up from local sources, from rainfall, snow, as well as seeping up through the bottom. And so we needed to dewater and clean up the contaminated water before we discharge it back into Lake Ontario. And so we also needed this so we can be able to do the rough and fine grading for the river valley. So you can see we had a single pump that was able to do it. We had an infiltration trench that allowed water within the excavation to accumulate, which was then pumped into a 3.1 million cubic liter water treatment facility with 2 large tanks and a detailed chemical treatment process that allowed us to reach safe Lake Ontario discharge water quality parameters, which we were ultimately able to pump into Lake Ontario after the treatment process. So that dealt with the horizontal barriers as well as the water treatment process. What we had to do as well was create a horizontal barrier. We had a series of risk management measures required to create a physical barrier between the remaining contaminated soils and groundwater below the river valley excavation area. And then we placed in overlying fills for rough grading, and then the finer soils for the various ecological units that we wanted to bring in, as well as the components of the levees, the river valley, and the vegetation that's forming the overall program. So we do remove 1.5 million cubic meters as part of the excavation. It's all impacted. So we were looking to find ways to remediate or relocate for final use as much as possible, rather than disposing, digging, and dumping. And so we had as well as the need to create a series of different solutions for the horizontal barriers before we start putting in the rough grading. And you can see we had a series of different design solutions with GCLs, geomembranes, reactive treatment layers, reactive core mats, and clean caps, depending on the level of contamination of the ground water and the soils that are within the area, as well as the expected range of shear stresses that would be exerted on the bed above under a major flood event. That will determine how much protection that we needed to put in place. So for the most part, the river, main part of the valley had the most complicated GCL, geomembrane, and activated carbon treatments. Some of our cleaner areas, which is a new area we're creating called Canoe Cove, which had much less contaminated soils. We're just dealing with sand caps. And some areas we're just dealing with the geomembrane based on the anticipated conditions. So you can see how we would have the native foundation, we'd have our drainage layer to facilitate seepage of the water during the dewatering process, the maintenance process. Then we would come in with the geosynthetic clay liner. Then we'd have the geomembrane, followed by an activated treatment layer. And then we'd have the various protective layers of rough grading and different materials that is provides a physical protection against scour. And then we'd have our different soils, topsoils, and treatments with vegetation of the naturalized area. And this gives you an idea of some of the geomembranes that we were applying. We basically gift wrapped the entire underlie of the river valley system. And then we overtop it with the reactive layer to deal with any contaminants that might get through the underlying layers treatment before it gets up to the protective layers. As you can see, this was earlier last year, the main river valley excavation and the wetland areas and the various locations where the RMM is in progress. How do you develop all this work? We had a very detailed risk assessment characterization process undertaken using community-based risk assessment that allowed us to consider all the different properties within the Portlands as a single site. It did allow us to characterize risks based on a property level, but allowed us to move soils from property to property based on like-for-like conditions within that area. So it did provide us quite a bit of flexibility to look at things comprehensively rather than a site-specific risk assessment, which would have been very challenging to do given the complexity of the multiple ownerships in the area. And then we also ended up doing a lot of bioremediation on site with very long biopiles with additives to accelerate the breakdown of hydrocarbons that were within the soils. So we were looking at 210,000 cubic meters through bioremediation. A lot of the soils we were able to move to future locations for direct placement, 800,000 cubic meters. And then out of that, we do have a significant amount of offsite disposal still, but it greatly reduced compared to the 1.5 million cubic meters of soils that is being removed. A lot of that, of course, is rubble, refuse, contaminated peats that was not possible to reuse. So as you can see, this is the bioremediation. We created very long piles where we had excavators going out daily, turning the soils over, maximize oxygenation with supplements to accelerate, bacterial supplements to accelerate the breakdown of hydrocarbons for reused materials. And of course, with the soils being heterogeneous fill, we had significant instability that we had to take into consideration. It was very geotechnically poor conditions. And so we had a range of different approaches to deal with the geotechnical conditions. We surcharged, basically put extra piles of dirt in areas to allow it to compress for a long period of time before we remove the extra material for the final grades. Where we didn't have the luxury of time, we created basically a foundation called rigid inclusions to underlie roads and other infrastructure that had caissons down to bedrock to support the weight of future municipal infrastructure. We were able to find some lightweight fill materials, and geogrid were some of the other approaches we did for ground improvement within the area. This is an example of the rigid inclusions where we had a road bed. We basically put in piles down to bedrock with a concrete foundation, a reinforced concrete foundation supported by the piles, and then we were able to place the municipal infrastructure on top of that foundation. It is very expensive, but it was the only way to work within the timeframes that we had. We couldn't afford the extra year or so of settlement if we went through the surcharge approach. And this gives you an idea of some of the geogrid and cellular concrete that we used in other locations to deal with geotech considerations. So this is a short 3-minute video of where we are on the project. It gives you an idea. It's narrated. Hopefully it works. Hopefully you can hear it. Okay. So, we're getting close to the end of the presentation, and we can take questions. Some other progress that wasn't included in the video is this gives you an idea of some of the ground improvement works where we're putting in the rigid inclusions for Commissioner Street, leading up to the Commissioner Street Bridge that came in last summer. And this is the two halves of the bridges that were brought in. And as you can see, there is an enclosed space that is required for the bridge operators to actually fuse the two bridges into a single unified structure. It is critical that we maintain climate and environmental conditions in which to allow that operations to work. So there is some very specific procedures required for the workers to access and undertake that activity. This is the location. In this is the diaphragm wall that I had alluded to. So the original dock walls were over near this boom. We installed the diaphragm wall in first. excavated the dock walls out, allowed Lake Ontario to come up to the diaphragm wall, and we're going to be installing the Cherry Street Bridge in this location. Once that bridge is in operation and cars are on that bridge, we'll be able to close the existing Cherry Street, which is just to the east, and allow us to excavate the rest of the river up to the other side of the diaphragm wall, at which point we'll be able to cut that diaphragm wall and connect the Colson Slip with the main river outlet in the future. And that's the new bridge that came in December for this location, and they're getting ready to put it onto the piers and abutments over the next little while. We have a lot of infrastructure that's in construction with contaminated soils. We have to create dedicated conduits for infrastructure connecting to the islands below the RMM layers. So we're using a series of micro-tunneling. And basically it is a non-excavation, and we'll not be able to access those infrastructure through the river into the future. So if there is a need for repairs or replacements, either needs to be done through the conduits or creation of new conduits to prevent the pathways of contamination to occur into the naturalized system in the future. We talked about the relocation of the Heritage Fire Hall. That was a significant amount of work over a year and a half to be able to stabilize and move that structure safely. There is some interest within the heritage components, which you'll get to shortly of the project. As you can see, we're using a mixture of hard engineering as well as softer bioengineering that deals with the bank and panel stability. We're creating a series of root wad cable jams. These are going to be stacked 8 trees high to provide bank protection as well as habitat for the vegetation. For the channel to establish in such time that the vegetation and rooting masses will be able to take over the stability of the banks. And similarly with the levees, we're dealing with a series of coir fabric lifts, which are staked with live stakes and will be inoculated with vegetation. So these stakes and the coir fabric will actually provide stability for the levee until such time that the rooting masses of the vegetation takes over. You can see they're driving on rock. That's the actual riverbed, and that's the materials that's going to be there once the river is flowing, but it does provide a good driveway to do operations from in the interim period. And of course, we had to pre-install the foundations for the pedestrian bridges that will be crossing the river throughout the area. These are going down about 8-9 meters depth. So they are quite the substantial structures for the pedestrian bridges in there. We did unearth some interesting archaeology. The original 1882 government breakwater that was formed the basis of the initial part of constructing the Portlands was unearthed as part of our excavation of the river. We had archaeologists on site as well as partner First Nation Mississaugas Le Credit monitors, undertook extensive topographic and survey and material survey, and recorded it for posterity before we removed it. There's some interesting video on our website that looks at the full process and the history of the breakwater. And as I said, this was a lot of garbage was used to fill in. So as we were excavating the valley system, the archaeologists were recording a lot of the artifacts and materials that were coming out of the ground: bottles, newspapers, clothing. So it was in the day of 1900s North America was underlying the entire Portlands area. Another unique thing that was coming up, we actually excavated down to one of the peat levels at the beginning of the summer, last summer, and then we went to work somewhere else. And by the end of the summer, with the rain that we had, we believe the seed bank from the original wetland from over 100 years ago began to germinate. So we actually had extensive amounts of river bulrush, cattails, and other wetland vegetations germinating from what we believe to be over 100-year-old seed. So we worked with TRCA, we collected all those materials, we've stored them at a nearby location, and we'll be including these historic seedlings in our restoration plan when we get into the planting later this year. We didn't, ironically, we actually didn't salvage them until after they went to seed this year as well. So not only did we get the actual seedlings, we got next year's crop from fresh seed germinated from the plants that grew in that location. So that was pretty exciting when that came about. So as you can see, a heck of a lot of work has been underway with regards to the project. This concept for a naturalized mouth of the Don was first identified by the task force to bring back to the Don back in 1989-91. The EA formally started in 2006 and was completed in 2015 for the river itself. We undertook in 2016 a due diligence study that took the river EA, combined it with the municipal class EA that was undertaken in parallel so that we can merge the two different EAs into a single project with a single scope, schedule, and budget. And construction commenced in 2018. We are now currently just approaching the spring of 2022 with most of the excavation completed. We plan to have some of the roads open this summer to allow us to finish some of the other excavation pieces where existing roads are located in the valley area. We are looking to do a lot of planting throughout 2022 and 2023. And we're looking to actually have the river flowing by the end of 2023 itself with the completion of the project in 2024. Once the river is complete, it does allow a whole suite of future revitalized community development to proceed. Villiers Island is one of the primary beneficiaries, which allows a whole new community, mixed-use community, to move forward with development plans and implementation. Keating Channel Precinct to the north. We have, of course, Quayside work, which you probably heard in the news recently, with the reissuance and the advancement selection of a development team to work with Waterfront Toronto to advance Quayside. And then, of course, we have the McCleary district. We have a bunch of the film studio areas, a warehouse district, and then, of course, what's not highlighted here is Cadillac Fairview's East Harbour precinct planning, which we are working with them and the city and Metrolinx for a broader project planning initiative in that location, which is also contributing to the flood protection of the overall program. And that's my presentation. Thank you very much. Is there any questions?
All right, fantastic. Thank you so much, Ken, for presenting. There are a number of questions. I believe there's 5 right now. So I'm going to start with the earlier ones. So the first one is, so are you designing flood protection for Hurricane Hazel, which is higher than the 100-year storm, correct?
That's correct. Yes.
I guess the question is, yes. Mm-hmm.
Yes, the design standard is much larger than the 1 in 100-year storm event. We are designing for Hurricane Hazel size event, and we're also adding an additional 50 centimeters vertical capacity to deal with engineering uncertainty as well as climate change. So we are putting anywhere between 10 and 20% more capacity above the Hurricane Hazel size flood event to deal with uncertainty.
Perfect. Second question, are there existing businesses in the area that will be displaced with the plan? Did they lease lands? How did you address the relocation?
There was some businesses within the area. Most of the properties that were required for the river were in ownership by Creatio, which is an arm's length real estate company holding company of the city of Toronto. They knew this project was coming along. The tenants knew this project was coming along for some time, and the tenants were operating off of 1-year renewable leases for the last several years in anticipation and knowledge that they would have to relocate. We did do a lot of accommodations. Some of the businesses that were on there were given some flexibility on the date in which they could stay, and we would work our schedule around them until they did have to leave. So there was an extensive effort to being able to phase the overall program to deal with when do we need the properties, and to ensure that there is sufficient time for the various tenants to be able to find a new location and get their operations underway in time for the for our needs, but also to make sure that we minimize the impact on the long term that did have to find a new locale.
Yeah, well, it's fascinating. It's a bit of a coordination there, I'm sure.
Huge amount, yeah.
Oh yeah. Now the third question. So when you dewatered and released the water, did you have to deal with the reduction in the river elevation and outlet to the lake? Did this affect water balance between the river and the lake, including temperature differences and possible chemical makeup?
The dewatering that we did was entirely isolated from Lake Ontario or the river. So where we had to dewater, it was within the existing land base. As such, we had no implications to worrying about adjacent water courses. Of course, we also had the horizontal and vertical barriers that were put in place that ensured that we're not drawing water as part of the dewatering process. And further, because we are at Lake Ontario, we couldn't have dewatered if we did not put those vertical barriers in place. There would have the volumes would have overwhelmed our pumping systems and treatment systems. So we were effectively able to entirely isolate the excavation from all external sources of water. And thus we weren't in a position where we would be impacting natural systems or dealing with overwhelming volumes of water with the excavation works.
Sure, thank you. Next question. How is the linear infrastructure, i.e. water, sanitary, storm, accommodated in this project?
It is, we're working very closely, as you can imagine, with the City of Toronto, as well as other utility companies. It's a major phasing process, as you could imagine, whereby we have to ensure that we're not cutting off services to tenants in the area that are still within the area and rely on that water. So a lot of the new systems are being constructed as part of the new roads that are underway. In some cases, the roads are being constructed in areas outside of the existing right-of-way. So we actually have we have to do a significant amount of legal surveys and being able to do a transfer over to the city as part of it, from private holdings to municipal right-of-ways with the associated easements and all that sort of fun. And of course, as we are developing those right-of-ways, we are pre-installing water and sanitary and stormwater systems as part of the right-of-way construction. It is a phased and drawn-out process. We do have a primary stormwater trunk that will be treating all of the stormwater from the roads for the entire island at a single treatment facility that will be treated and then discharged into the Keating Channel. So we have pre-installed the main trunk, and as roads are constructed over time on the secondary road areas, that we'll provide feeders based on those new road systems to tie into the trunk system itself. With the water and the sanitary, because we are located on an island, we do have to build in a pumping system for the sanitary to go underneath the river and underneath the barriers. Like the other servicing, we can't penetrate into the barriers to prevent the migration of contaminants from the natural with that. And we're also doing a lot of micro tunneling for the water mains and the pressurized water main systems below the river system to be able to pre-install that infrastructure as part of the overall program.
Okay, perfect. That's a great answer. A few more questions here, if you don't mind. Next one. Hi, not sure if this is a suitable question or not, but are there any plans to add a new ramp to access or leave the Gardner? Not the same as what was removed, but something to alleviate the traffic chaos that is seen now in the area.
Apologize for that. We knew that was going to be the biggest challenge is the Gardner. It's going to be the chaos is going to be there for a while longer. The portion that it's part of a larger EA that was undertaken by Waterfront Toronto and the city. Basically, we are doing the first phase of that project. It was only added to our program last year. Mainly because it was very difficult to build a new lakeshore bridge for the river while we had an active Gardner above it. So, we decided to work up the city to agree to advance that portion of the Gardner removal and reconstruction of lakeshore. The city will be following our work in 2025 with the rest of the Gardner that ties in with the DVP to tear down those two ramps and then create two new ones that are shifted further north so that we're not occupying most of the lands north of the Keating Channel so that we can maximize development options. So there will be new ramps in there. There will be a realignment of lakeshore as well. Once you're over the Don River, it'll be shifted towards the north as well instead of along the Keating Channel to again open up the Keating Channel for the public. And as part of that lakeshore relocation, there will be a ramp, I believe, added that will provide access up to the Gardner at that time, but that is several years down the road. So that's, I believe that that second phase of the work comes between 2025 and 2030 or so.
Mm-hmm. Okay. Two more questions. First one is, are there any plans or provisions that are being made for transit?
Yes, there is. There is ultimately, what I didn't get into is most of the bridges, the new Cherry Street bridges and the Commissioner Street bridges there is an allowance for twinning. One bridge will be for vehicles, the other will be for a BRT up front, and then later an LRT. There is extensive planning underway that ties in with Quayside as well as the Cherry Street underpass going up to the West Don lands to create LRT track system alignment that will eventually be able to cross the Keating Channel and then the naturalized river at Commissioner Street through dedicated transit ways. We only had funding for the first of the LRT bridges, which is the one that will be at the new Cherry Street that goes over the Keating Channel. We are currently in planning for the next phases beyond the flood protection project that gets into the Villiers Island that is looking to include the remaining LRT bridges to get onto the island.
Okay, perfect. And one final question, what is the status of the Unilever property?
The status of the Unilever property, as I mentioned earlier, is owned now by Cadillac Fairview. We are working very closely with Cadillac Fairview. They are, of course, very interested with the new works on what Lakeshore is going to look like and the infrastructure that we're placing there. They have a whole range of infrastructure needs for their massive development. It also ties in their property. They need to build part of the flood protection solution by raising the grades along the Don roadway between Lakeshore and the railway embankment. And so there's a whole site plan application underway through the city. Waterfront Toronto, TRCA, and other agencies are part of that review process to ensure that their planning is in conformance and timing with the overall flood protection solutions. And we're actually working closely with them to find ways to find efficiencies for what we're proposing for infrastructure along Lakeshore and with what they need following us shortly. So there's a lot of efforts to dovetail and make sure it's a systematic and comprehensive integration between their program and the program that we have underway here.
Okay, wonderful. Well, that has been all the questions. And Ken, I guess we have OPWA and all of us, thank you so much for an amazing presentation. I'm sure everyone had a very informative time. And again, thank you very much. And Thank you, everybody, for attending.
My pleasure. Thank you very much for inviting me. It's very much appreciated.